This is lesson 10, which is about adverse weather. So in a previous couple of lessons, we talked about weather conditions that create good conditions for soaring. This time we're going to talk about weather conditions that you want to avoid. We're going to start by talking about air masses and fronts, obstructions to visibility, ceilings, wind, then we'll get into thunderstorms, which you really want to avoid, wind shear, and then we're going to have another segment on aeronautical decision making that's focused on weather questions. So air masses and fronts. Across the Earth, there are a bunch of air masses that form, and they gradually they form over one place on the Earth, and they get properties that are kind of based on the that location, and then they move around and they take those properties around with them, and they interact with air masses in other places as they move around. So the boundaries between air masses are called fronts. The weather near the front depends on the characteristics of the two air masses and which mass is moving in and which mass is being pushed out. So this picture shows a sort of a cross-sectional view of a cold front where we've got a cold air mass moving in and displacing a warmer air mass. When that happens, air in the warmer air mass, because it is less dense, gets pushed upward quite quickly. That cold air mass comes in and pushes under it, and the warm air goes up. Frequently, warm air masses also tend to have moisture in them. Not always, but it's common for a warm air mass, since warm air can hold more moisture, it's common for that warm air mass to have moisture. When that happens, you've got moist, warm air being pushed up rather quickly. That's a really common situation for thunderstorms to form, like right at the front and out in front of the front. A warm front is when the warm air is moving in and displacing cold air. So the warm air in this case, instead of pushing under that cold air like the cold air did, it will tend to go over the top of the cold air. It will be the warm air that's moving in that tends to get pushed up, but it tends to get pushed up much more gradually than in the case of a cold front. That causes different types of clouds to form and different types of precipitation situations. Tend to get stratus clouds, which are uh, over a wide area and not necessarily that thick. They tend to cause rain that isn't super intense, but that happens over a long period of time. Usually the air ahead of the front is stable, and that can lead to some um, lower visibility situations because the things that would interfere with visibility don't get mixed around a lot. In a previous lesson about the National Airspace System, we learned that there is a certain visibility requirement in order to be able to legally fly VFR in different types of airspace. But beyond being legal, there are a lot of reasons why we care about how far we are able to see. One of the first is that it limits how far ahead you can see the land, and the farther ahead you can see, the easier it is to navigate. Also, when visibility is low, it tends to obscure the horizon in a lot of situations. And when you can't see the horizon very clearly, that makes pitch control harder because we tend to rely on being able to see that horizon in order to have good control of our pitch attitude. And then, of course, seeing and avoiding other traffic. Some of the things that get in the way of having good visibility, one of the worst culprits is fog. Fog occurs whenever the temperature and the dew point are close together and getting closer. There's a variety of different types of fog which develop in different situations where that cause the temperature and the dew point to get closer together. But fog is going to dramatically reduce the visibility when it happens. Rain, uh, usually the type of rain that is associated with a warm front, visibility tends to be a big problem. Smoke. Smoke can happen if there's forest fires in the area. And as we discovered last summer, even when the forest fires are a long ways away, like way up in Canada, smoke in the atmosphere can reduce the visibility from a long ways away. Pollution. In certain parts of the country, this is more common than in others, but in areas where there's a lot of pollution and the wind isn't good at pulling that pollution away, visibility tends to be low. Ceilings refer to how high the clouds are uh, in your area. Specific for the legal definition of a ceiling is any cloud layer that is covering more than 50% of the sky. It's and the base of those clouds would be the ceiling. You need at least 1,000 feet ceiling in order to legally fly VFR. In practice, for flying with a glider, you need quite a bit more than that to do anything more than maybe pattern toes. Low ceiling limits how high you can get, which determines how far you can get from an airfield. And we like to stay in gliding distance of the airfield all the time. So we need we need a decently high ceiling in order to get very far away from the airport. And when we're looking for thermals, if we get in a good thermal, the ceiling's going to limit how high we can climb in one thermal, which will limit how much time we have to find another one after we leave that thermal. So knowing what the ceiling is somewhat difficult. You can't really just look up from the ground and look up at the clouds. It's very difficult to accurately judge the height of the clouds. So the best ways to determine the ceiling, official weather reports will give you the ceiling at certain locations where there's equipment to measure them. If you're at a place that doesn't have that equipment, then reports from pilots that that have flown recently is a good way to know. Um, Generally, our tow pilot will take a flight in the area before we start the day. The tow pilot will usually be a good source of information about what the ceilings are right now. If you don't have either of those, any of those sources of information, a rule of thumb for estimating the ceiling is to take the temperature dew point spread in degrees Celsius and multiply by 400 to get the ceiling in feet above ground level. I know that's mixing metric units with English units, but usually the weather reports that give you temperature dew point spreads give them to you in degrees Celsius, and we when we need to know the ceiling, we usually want it in feet, so that's intentional to mix those units. Another type of adverse weather condition we need to consider is the wind, both surface winds and winds at altitude. So at the surface, wind tends to make it more difficult to land and to take off. That's especially true of crosswinds and gusty winds. With a power plane, if you encounter a gust when you're close to landing, you can go around and come back and take another try. With a glider, you don't have that choice available. Unfortunately, the conditions that tend to produce good thermals also tend to produce gusts near the ground level. So to some extent, dealing with gustiness is kind of a necessary evil for us as glider pilots. But when their gusts are especially strong, that's maybe a situation we just want to stay on the ground and avoid. Wind at altitude impacts us differently. We're not, it won't affect our takeoffs and landings, but we need to get, it can change how far we can fly from a given altitude and make it difficult to cover the ground. If we get ourselves downwind of the airport, it can be really hard to get back. So when the winds are strong at altitude, it's important to make sure you're keeping track of where you are compared to the airport and staying upwind. Wind can also make thermals, it interferes with the formation of thermals and tends to break them apart, makes them harder to stay in when you do find them. So sometimes you'll get a wind, an abrupt change in wind speed over a small amount of altitude change. When that happens, especially if it's close while you're on approach for landing, you can get a rather sudden change in your airspeed as you go across that altitude change. Being aware that that is likely to happen will make you less likely to be surprised by it, and you will address it more quickly when it does occur. Thunderstorms. These are something you definitely don't want to be messing with. Um, Thunderstorms tend to form when there's an unstable atmosphere, a high temperature lapse rate, and sufficient moisture in the air. Um, Unfortunately, some of the same things that produce good thermals are things that produce thunderstorms. So it's kind of a too much of a good thing kind of situation. If you get a day that may start out really good, where you've got some nice little cumulus clouds marking where the thermals are, if it gets too much, those cumulus clouds can turn into thunderstorm clouds. So we talked earlier about thunderstorms forming along a cold front. Thunderstorms can also form in the middle of an air mass. The air mass thunderstorms usually tend to happen in the afternoon when the convective activity is the strongest. And the air mass thunderstorms tend to be the ones that are most problematic for us as soaring pilots because we tend not to be out in the cold front situation very often. This graph kind of shows, or this picture shows some of the different stages of formation of a thunderstorm. During this cumulus stage, that's when there's a lot of updrafts going into the thunderstorm, moisture's going up, the clouds are building. This is not an especially dangerous stage for us In fact, it can be a very nice stage because we love these updrafts as long as they're not so strong that they're pulling us up into the cloud. The mature stage of a thunderstorm is when the rain's happening. So you get a lot of the water coming out. There may still be strong updrafts and strong downdrafts, both happening in the middle of the cloud and also in the area underneath it. At the dissipating stage, that's where the really heavy rain has already occurred, but it's still raining. But we really want to be nowhere near these clouds during the mature stage, even to the side of them. So there are some weather data that's available that helps us predict the likelihood of thunderstorms developing. This is a index called the K index, which tells us whether we should be worried about thunderstorms that day. That's available in some reports, and you just have to look at how high the higher the index is, the more likely is thunderstorms will happen. The lifted index indicates how likely any thunderstorms that happen will be severe. Both of these indices there are formulas for them, which are based on dew points and temperatures at different altitudes, and I don't have the formulas memorized. So the lifted index and the K index are different than the thermal index, which is used to predict whether the thermals will be good. All of them are measures of atmospheric instability, but they're kind of geared towards predicting different things. So now I'd like to revisit the topic of aeronautical decision making and talk specifically about weather issues and how weather issues involve our aeronautical decision making. So if you recall our previous discussions of aeronautical decision making, that requires us to notice when conditions change, estimate how those changes should impact the plan that we've made, and then revise our plan accordingly. And in a previous lesson, we talked about this PAVE acronym, which describes 4 categories of factors that we need to be considering when we're making plans and updating plans. The lesson today is going to talk about the V in PAVE, which stands for environment. Other categories there were discussed in either in lesson 4 or will be discussed in a future lesson. So I'm going to present some scenarios with weather situations here. I want you to think about these scenarios and think about how they would change your decision making. And when we get together as a group, we'll discuss these and some other scenarios and the decision making around weather issues. So consider that when you're driving to the airport in the morning, along the way you drive past some little lakes and things, and you notice there are areas of fog a few places. So you were planning to just get going right at 8 o'clock, but when you notice that fog, how would that influence your plans for soaring that day? Or you're looking at the weather conditions and they look really good for soaring in the early afternoon, but the forecast calls for a chance of thunderstorms later. How would that impact your decisions for soaring that day? Okay, when you're checking the weather before your plan to go soaring, you notice that there's a cold front that's forecast to move over your airport this evening. It's going to come from the northwest. So you were planning to do an out and back cross country flight today, and you have to pick a place that you're going to go as your choice of your destination for your out and back cross country task. How would the fact that there's a cold front coming in from the northwest impact what would be a good choice? So suppose you're in flight. What things do you need to be looking out for out the window and weather sources that are available to you in flight for you to know whether thunderstorms are likely to develop in the next couple hours while you're still up soaring? Okay, and while we're on the topic of aeronautical decision making, I want to talk about something kind of specific to soaring. We do our soaring activity in a club environment. It's kind of different than a lot of other types of aviation activity where it's much more individual. And that has some pros and cons in terms of how it affects our aeronautical decision making. I think it's worthwhile to be conscious of those pros and cons. One of the advantages to being in a club environment is that there's usually experienced pilots around, and the less experienced pilots have somebody to consult with when they're making decisions about their plans for the day and whether to the go no go decision. One of the disadvantages that kind of goes hand in hand with that, though, there's a tendency to assume that other people are thinking about things and are making decisions for you. Uh, Tend to think, oh, the officer of the day is watching the winds for me, or um, instructors are busy. They're taking care of, they would be canceling if it was too windy. So I don't need to be thinking about that. A good thing is that there's lots of eyes looking out for changes. Bad thing sometimes it isn't clear who should make certain decisions. The wind maybe at Sand Hill is starting to blow from the north a little more, and we have to just you know have to decide should we reverse our operations and start taking off to the north. But maybe the tow pilot thinks the officer of the day is making that decision, and the officer of the day thinks the tow pilots or the instructors are making that decision, and nobody makes it because everybody thinks somebody else is making it. We have to be wary that that can happen. An advantage of being in a group environment like that is that the hazardous attitudes that we talked about in a previous lesson there's a good having a lot of people around that can spot hazardous attitudes in other people is a good thing. The, when you spot a hazardous attitude in other people, you can give them the antidote. If they don't spot it in themselves, maybe you can help correct for it by talking to them. The downside to being in a group is that when somebody has hazardous attitudes, those sometimes tend to get a little contagious. One person feeling that way and talking, getting a little macho can lead other people to macho to try to match them, or the some of the other hazardous attitudes when other people display it, new students especially, but even experienced pilots can kind of accept it as normal and start to model that behavior.